It is 1971. Somewhere deep in a NATO operations room, a sonar operator is watching something impossible. The contact is moving at 41 knots, underwater. That is faster than most surface warships at full sprint, and this is a submarine. The room goes quiet. Not because the contact is a secret. NATO has known about this class of vessel for years. The terror isn't that they can't find it. The terror is that if it decides to run, nothing in the ocean can catch it. No torpedo of the era is fast enough. No Allied submarine is close. The Soviets had built something that rewrote what underwater warfare was supposed to be. And it was completely useless in a war. To understand how the Alfa-class reached that speed, you have to understand how extreme every single design choice was. This wasn't a submarine that got an upgraded engine bolted onto a conventional hull. It was a machine built from first principles around a single obsession: go faster than anything that might be fired at it. The hull was titanium, not steel, titanium. Lighter, stronger, and capable of withstanding pressures that would crush conventional submarine hulls at depth. That allowed the Alpha to dive significantly deeper than anything NATO had in service. But because a higher crush depth meant the hull walls could be built thinner, thinner meant lighter, and lighter meant faster. Every engineering variable was downstream of speed. The reactor was the key to all of it. The Alpha used a liquid metal reactor cooled with lead bismuth alloy, a design so compact and so powerful that it could push a 3,000-ton submarine past 41 knots. The crew was small, the hull was small, the power output was extraordinary, the formula was ruthlessly efficient. On paper, the Alfa-class looked like the most dangerous submarine ever built. Here is where it starts to fall apart. At 41 knots, a submarine's propellers don't move through water, they assault it. The blades spin fast enough to drop the local water pressure below its vaporization point, creating millions of tiny vacuum bubbles that form and then collapse violently in rapid succession. That process is called cavitation. It sounds like wrapping the entire hull in continuous static mixed with gravel and impact noise, and it is extraordinarily loud. At top speed, the Alfa-class was one of the loudest objects in the North Atlantic. Not loud for a submarine, loud by any measure. Every passive sonar array NATO had deployed on the ocean floor, every hydrophone listening post, every Allied attack submarine in range, all of them heard the Alpha the moment it opened up. It was acoustically unmistakable. NATO analysts had a nickname for it: the automatic submarine. Not because it was automated, because the moment it hit full speed, it automatically broadcast its exact position to every sonar operator in the Atlantic. The weapon designed to be uncatchable was handing out its coordinates for free. But the noise problem had a second layer that made the first one look minor. The Alpha's sonar worked on the same principle as every other submarine's sonar. Passive listening. Hear what is in the water. Torpedoes have acoustic signatures. Other submarines have acoustic signatures. Surface ships have acoustic signatures. All of that information arrives through the water as sound, and a submarine that can hear is a submarine that can survive. At 41 knots, the Alpha's own propeller noise drowned every single one of those signals. The broadband static that was broadcasting its position to NATO was simultaneously destroying its ability to detect anything at all. Running at full speed, the Alpha was acoustically blind. Consider what that means in practice. The entire tactical concept of the Alpha was to sprint away from incoming torpedoes to outrun the weapon before it could reach the target. But at sprint speed, the Alpha couldn't hear whether torpedoes had been fired. It couldn't track what was closing behind it. It couldn't process any sonar contact at all. It was running at 41 knots through water it could no longer read, executing its escape maneuver in a complete information vacuum. Operators trained on the Alpha were trained to use its speed as a survival tool. What they were actually doing was trading every piece of information they had in exchange for velocity. That trade-off assumed the speed alone was enough. It wasn't. The speed came from the liquid metal reactor. And the reactor came with a constraint that had no workaround anywhere in the engineering. Lead bismuth coolant has to stay above 125 degrees Celsius, not to operate, just to remain liquid. Drop below that threshold and it solidifies. When it solidifies inside a reactor vessel, it does not cause a maintenance problem. It destroys the reactor core permanently, in place, with no recovery option. This meant the Alpha-class submarine could never be completely shut down. Every boat required a dedicated shore heating system permanently connected whenever it was in port. Special insulated piping, continuous thermal infrastructure, around-the-clock power supply to the heating elements. Not while the reactor was running at operational output, while the boat was tied to the dock, while the crew was on leave, while the submarine was waiting for sailing orders. The fastest submarine ever built required constant life support just to remain intact. There was no procedure for an orderly cold shutdown, no option to take the boat offline for extended maintenance and restart it weeks later. The reactor was either kept alive continuously or it was gone. That was the literal operational reality of every Alpha-class boat in the Soviet Northern Fleet. In a conventional fleet, this kind of overhead compounds. Maintenance windows require cold shutdowns. Crew rotations require a period where the boat is effectively quiet. The Alpha couldn't do any of that cleanly. The shore infrastructure had to stay running. The thermal management had to stay continuous. Every Alpha home port carried a permanent logistical burden that had nothing to do with weapons, sensors, or crew. That infrastructure also glowed. Thermal signatures from Alpha support facilities were visible to NATO intelligence. Analysts could track which boats were in port, how long they had been sitting, whether the heating systems had been disrupted. The submarine built to sprint away from detection was surrounded by a permanent thermal signature, broadcasting its precise location every day it spent in harbor. In 1972, K-64, the first Alpha-class submarine ever commissioned, suffered a coolant casualty in port. The lead bismuth solidified. The reactor was destroyed in place. The boat was decommissioned and never returned to service. A subsequent Alpha suffered a similar event. The most advanced propulsion system ever installed in a combat submarine turned out to be acutely fragile to exactly the kind of disruption that real-world naval operations involve. Here is the chain, written out plainly. The Alpha was fast because of the reactor. The reactor required liquid metal coolant. The coolant required constant heat. The constant heat required permanent shore infrastructure. The infrastructure was visible to NATO intelligence. The speed created cavitation. The cavitation generated broadband noise. The noise revealed the Alpha's position to every sonar array in the Atlantic. The noise also destroyed the Alpha's own sonar. And the Alpha's sonar was the only tool that could have made the speed survivable in actual combat. Every component of that design was genuinely extraordinary, and every component quietly undermined every other component. This is not a story about Soviet engineering failure. Soviet engineers built an extraordinary machine. This is a story about what happens when a design chases individual performance metrics without checking whether those metrics can coexist under real operational conditions. The Alpha achieved everything it was designed to achieve. It just turned out that those achievements canceled each other. 7 Alpha-class submarines were built. The class was retired well ahead of its intended service life, not because something better replaced it, not because it was destroyed in combat, but because the gap between what the Alpha could theoretically do and what it could practically do in a real conflict was never closed. None of them ever fired a weapon in anger. The fastest combat submarine in history never needed to move quickly in a fight. It never had a fight. The 41 knots that terrified NATO existed entirely in simulations, intelligence assessments, and contingency planning documents. The real Alpha-class spent its operational life generating logistical problems, losing reactors in port, and reshaping Western defense spending without ever demonstrating the capability it was supposedly built around. And yet, NATO did spend those years and significant resources redesigning its entire submarine doctrine around the Alpha's theoretical threat. Faster torpedoes, quieter attack submarines, better sonar processing. The response to the Alpha changed how Western navies operated for a generation. The Alpha win its war entirely by existing. That original contact, blazing across the board at 41 knots, apparently unstoppable, was a machine in the process of defeating itself. The speed was real. The terror was real. The uselessness was built into the same design decisions that produced both. The problem the Alpha revealed, a capability that destroys itself the moment it is actually used, has not gone away. There is a class of modern high-speed underwater platform still in active service that faces the same fundamental paradox. The faster it goes, the louder it becomes. The louder it becomes, the more visible it is. And in the environment it was built to operate in, visibility is the one thing it cannot afford. The engineers know, the operators know. 60 years after that contact crossed a NATO sonar screen, the answer is still the same as it was then. Nobody has solved it yet.